Welcome to Lesson 19 on the law of sines. Finally, we have some properties in trigonometry that will apply to triangles that are not right triangles. When we say that we are solving a triangle, we mean that we are finding the measures of all the angles and all the sides in a triangle. The law of sines says to let ABC be any triangle. By any, we mean that it does not have to be a right triangle. So it is any triangle with A, B, and C representing the measure of sides opposite the angles with measures A, B, and C respectively. So in this particular triangle, I have side A opposite angle A, side B opposite angle B, and side C is opposite angle C. It's very important that you set up the ratios for the law of sines matching up the sides with their opposite angles. What the law of sines says is the sine of angle A divided by side A will equal the sine of angle B divided by side B, which will also equal the sine of angle C divided by side C. We will do an example below to show how this is typically used. So we are going to try to solve this triangle. That means that we need to find all the sides and all the angles, and some information has been given to us already. Well, your handout already indicates that side Z is 14. You will need to add the information that angle X is 33 degrees and angle Z is 47 degrees. This information is given as part of the problem. The easiest thing to find first would be angle Y. If I know two angles of a triangle, I can subtract from 180 to find the third angle. So in this particular case, I would find that the measure of angle Y will equal 180 minus 33 minus 47. Therefore, the measure of angle Y equals 100 degrees. In order to use my law of sines, I'm going to set up the law here, the entire equation, all three parts, using the angles that I know. I know X, the degrees for angle X is 33 degrees. I just calculated that angle Y is 100 degrees. And it was given to me that angle Z is 47 degrees. I don't yet know sides X and Y, but I do know that side Z is 14. And I can use this complete ratio in order to find X or Y. In order to find X, I'm going to set up just a piece of it. Sine 33 degrees divided by X will equal the sine of 47 degrees divided by 14. To find the sine of 33 degrees, I would again use my calculator. What I would do is I would press the sine button, I would put in 33 degrees, close the parentheses, and find that the sine of 33 degrees is actually 0.54. So I can substitute that now in my fraction. So 0.54 divided by X will equal the sine of 47 degrees, which I would also find using my calculator, and it comes out to be 0.73 all over 14. I now have a simple proportion or ratio. So what I would do in order to solve is the good old-fashioned cross multiply. And when I do that, what I'm going to find is that 14 times 0.54 will equal 0.73 times X. In order to solve for X, I will divide both sides by 0.73. And when I do this in my calculator, I will find out that X is approximately 10.4. That means I now know that side X is approximately 10.4 units. And remember, we already found the measure of angle Y to be 100. In order to find the measure of side Y, I'm going to use just this piece here of my equation. So I would set that up as, over here, the sine of 100 degrees divided by y will equal, again, the sine of 47 degrees over 14. I've already found the sine of 47 degrees. I can put sine of 100 in my calculator and find that I get 0.98 divided by y will equal 0.73 divided by 14. Again, I would do some cross multiplying, okay? And when I do that, I would find out that y will equal 18.8. So y will be equal to 18.8. And that would be the length of my last side. And that's an example of how we use, how we use the law of sines to find angles or sides of any triangle that we don't already know those for. It does not have to be a right triangle.
Oops!